Have you ever looked up at the sky and seen a plane soaring high above, leaving a long white trail behind it? It's an amazing sight, isn't it? That incredible feat of engineering is made possible by a truly marvelous invention: the jet engine. Think of it as the powerhouse, the beating heart of the aircraft. It's not just an engine, it's a machine that breathes in the air around it and uses it to push a massive metal bird through the atmosphere at incredible speeds. The science behind it is both elegant and powerful, a perfect demonstration of physics in action. We use them because they are uniquely suited for flying high and fast, much more efficiently than propeller engines at those altitudes. So what exactly is a jet engine? At its core, it's a type of engine that creates thrust by shooting out a high-speed jet of hot gas. It's all based on a very famous rule from a scientist named Isaac Newton. His third law of motion says that for every action, there is an equal and opposite reaction. Imagine you're standing on a skateboard and you throw a heavy ball forward. What happens? You and the skateboard roll backward. The jet engine does something very similar. It throws a massive amount of hot air out the back at very high speed, the action. And this pushes the entire airplane forward, the reaction. It's that simple, yet that powerful. Unlike the engine in your family car, a jet engine doesn't have pistons moving up and down. Instead, it's a continuous flowing process. It's more like a controlled continuous explosion happening inside a strong metal tube. This continuous flow is what makes jet engines so smooth and powerful, allowing them to generate the immense force needed to lift hundreds of tons of metal, cargo and people off the ground and carry them across oceans and continents. They are the reason we can travel from New York to London in just a few hours, something that would have seemed like pure science fiction just over a century ago. The purpose of this magnificent machine is to conquer the skies. Before jet engines became common, airplanes used propellers to pull themselves through the air. Propellers are great, but they have their limits, especially when you want to go really fast or fly really high where the air is thin. Jet engines excel in those conditions. They are designed to be most efficient at high altitudes and high speeds, making them the perfect choice for modern airliners and military jets. They have truly shrunk our world, connecting cultures and economies in a way that was never before possible. Let's take a closer look at how they do it. To understand how a jet engine works its magic, we need to look inside. It might seem complicated, but we can break it down into a few main parts, each with a very specific job to do. First up, at the very front, you have the fan. This is the big set of spinning blades you can see when you look into the front of an engine. Its main job is to suck in enormous amounts of air. A lot of this air actually goes around the core of the engine, which helps with thrust and makes the engine quieter. The rest of the air is directed into the engine's core, beginning its journey. Next in line after the fan is the compressor. Think of the compressor as a series of smaller, powerful fans, all spinning incredibly fast. Its job is to take the air from the main fan and squeeze it. It squeezes it a lot. Each set of blades in the compressor makes the air tighter and tighter, increasing its pressure and temperature. By the time the air leaves the compressor, it is super compacted and very hot. You can imagine it like pumping up a bicycle tire. The more air you force into the small space of the tire, the higher the pressure gets. The compressor does this on a massive scale. After the air has been squeezed, it moves into the combustor or the combustion chamber. This is where the real fireworks happen. In this chamber, the highly compressed hot air is mixed with a fine mist of jet fuel. Then, an igniter, much like a spark plug in a car, lights this mixture on fire. But this isn't a single explosion. It's a continuous, controlled burn, creating a torrent of extremely hot, high-energy gas that wants to expand very quickly. It's like a non-stop, roaring furnace contained within the engine, releasing a tremendous amount of energy in a controlled way. Finally, at the back of the engine, we have the turbine and the nozzle. The super hot, high-pressure gas from the combustor blasts through the turbine. The turbine looks a lot like a windmill with many small blades. The force of the rushing gas spins the turbine at incredible speeds. Here's the clever part. The turbine is connected by a long shaft all the way back to the fan and the compressor at the front. So the energy from the hot gas is used to spin the turbine, which in turn powers the compressor and the fan, keeping the whole cycle going. The remaining gas then rushes out the back nozzle, creating the powerful thrust that pushes the plane forward. The entire process of how a jet engine works can be summed up in 4 simple, memorable steps: suck, squeeze, bang, and blow. It's a continuous cycle, a perfectly choreographed dance of air and energy that repeats thousands of times per second. First comes suck. This is the job of the giant fan at the front of the engine. As it spins, it pulls in or sucks a huge volume of air from the atmosphere. A single large jet engine can swallow the amount of air in an entire school gymnasium in just a few seconds. It's a powerful vacuum cleaner for the sky, gathering the main ingredient the engine needs to work: air. Next in the sequence is squeeze. The air that was sucked into the engine's core is now passed to the compressor. This section is made up of many rows of spinning blades that get progressively smaller. Their job is to squeeze the air, compressing it into a much smaller space. This increases the air's pressure immensely, up to 40 times the normal atmospheric pressure. When you compress a gas, it also gets very hot. So, by the end of this step, the engine has a supply of very dense, very hot air, packed with potential energy and ready for the next stage of the process. This step is crucial for making the combustion powerful and efficient. Then comes the most exciting part: bang. The highly compressed hot air is forced into the combustion chamber. Here, it is mixed with a spray of jet fuel, and this mixture is ignited. This creates a controlled, continuous explosion, or a very rapid burn. The bang isn't a one-time event, but a sustained roar of fire. This reaction releases a massive amount of thermal energy, causing the gases to heat up to an incredible temperature, sometimes over 2000 degrees Celsius. This super hot gas expands violently and needs to escape somewhere, creating the immense pressure that will drive the final step of the cycle. Finally, we have blow. The tremendously hot, high-pressure gas has only one place to go: out the back. On its way, it rushes past the turbine blades, spinning them at high speed. This spinning action is what powers the compressor and fan at the front, making the engine self-sustaining. After passing the turbine, the jet of hot gas blasts out of the rear nozzle at speeds of over 1,000 miles per hour. This powerful blast of gas shooting backward, the action, creates an equal and opposite force that pushes the engine and the entire airplane forward, the reaction. And that, in a nutshell, is how we fly. So why are these engines the undisputed champions of modern aviation? Their importance comes down to their incredible efficiency at doing what they do best: moving airplanes at high speeds and high altitudes. Propeller planes are great for lower, slower flight, but as they try to go faster, the tips of the propellers can start moving faster than the speed of sound, which creates a lot of problems and limits their top speed. Jet engines don't have this issue. They are most at home in the thin, cold air found miles above the Earth, where there is less air resistance, allowing planes to travel faster while burning less fuel than they would at lower altitudes. Here's an interesting fact to consider. The inside of a jet engine's combustion chamber gets so hot that it can melt the very metal the engine is made from. So how does it not destroy itself? Engineers have designed a clever cooling system. Some of the cooler air from the compressor is bypassed around the combustion chamber and piped through tiny holes in the chamber walls and turbine blades. This creates a thin layer of cooler air that acts as a protective shield, preventing the super hot gases from melting the engine's components. It's an amazing piece of engineering that allows these machines to operate under such extreme conditions. The impact of the jet engine on our world is simply monumental. Before the dawn of the jet age in the 1950s, crossing the Atlantic Ocean was a long and arduous journey by ship that took days. Today, a jetliner can make that same trip in about 7 hours. This incredible speed and efficiency have connected the globe, making international business, tourism, and cultural exchange a part of everyday life for millions of people. It has made fresh food from across the world available in your local supermarket and allowed families to live thousands of miles apart, while still being able to visit one another relatively easily. In conclusion, the jet engine is far more than just a piece of machinery. It is the engine of globalization, the heart of modern travel, and a testament to human ingenuity. By mastering the simple principles of suck, squeeze, bang, and blow, we have unlocked the ability to soar through the heavens, shrinking our planet and expanding our horizons. The next time you see a plane gracefully gliding across the sky, take a moment to appreciate the incredible science and engineering at work inside those powerful pods under the wings, continuously pushing us forward into a more connected future. Science is everywhere, even 35,000 feet up.